All right, we're going to continue with example 2, part C. Okay, this one is just the integral of a constant, and from the properties we see that this is just going to be 5 times b minus a. Again, the idea is that this just creates some kind of rectangle from a to b, so the area of a rectangle is just length times width, so that makes a lot of sense. Okay, and since we do not know what a or b are, we just leave it at that. If you want, you can distribute the 5. Okay, for problem D, we have two properties here. First of all, we have the addition of two functions. We could take the integral independently of each function, 5 and g of x. And if we do that, we get the integral from a to b of 5 dx plus the integral from a to b of g of x dx, right? And they tell us what the integral from a to b of g of x is -3. So this just becomes 5 times b minus a plus -3. Okay, or minus -3 if you want. And since we don't know what b and a are, we just leave it like that. Okay. For problem E, we see again another property where you're taking the integral of two functions. I'm not sure, did I say the derivative over here? Well, if I did, I meant the integral. So for the integral of f of x minus h of x, we could split this up into their individual integrals for each function. And if we look back, what is the integral of f of x? It's going to be 8. And the integral of h of x from a to b is going to be 5 over 2. And we just do a little bit of arithmetic, and we should get 11 over 2. Okay. All right. For the next one, this one, they're actually, again, you're seeing that you have the sum of two integrals from a to 4 and then from 4 to b. If we were to go back and look at that property, right? What property was that? That was it this property? Nope. It was this property here, the additive interval property, right? Where you're saying the integral from a to b can be seen as the addition of two integrals, or two intervals that you're splitting, right? A to c and c to b, but together you would go from a to b. So that's what they're kind of doing in this problem. So we could actually write this, the integral of a to 4 h of x plus 4 to b of h of x is just going to be the integral of h of x from a to b. Okay, and what is that equal to? From our notes, I think they said that was 5 over 2. Okay, there you go. All right, let's look at example 3. This one you get a little bit more arithmetic involved, but again, they're asking you to find the integral of f of x dx from 1 to 5. And we see it's embedded in there, right? But we have to use our properties to break it up, kind of expand this problem. And I already see that we have a 3 here, so that would be a factor we could take out. And we have some addition rules, and all that is going to be equal to 34. So let's go ahead and do the first step. This is going to be equal to 3 times the integral from 1 to 5 of f of x dx plus the integral from 1 to 5 of 4 dx is equal to 34. And I could simplify this, and I could just take out the, I know I have to get rid of that 3 to be left alone with the f of x, the integral of 1 to 5 for f of x dx. So let's figure this one out. Again, using our rules, our properties, there's a constant. It's just going to be 4 times b minus a, and that gives us 16. And that shouldn't be a plus. I mean, that should be a plus, not a equal sign. Okay, and we have this. All right, subtract 16 to both sides. And that should give us 18. And again, I want to get rid of that 3 because our question is asking us to find this integral by itself. And by doing that, we're left with just the integral from 1 to 5 of f of x dx with respect to x, and that's going to be equal to 6. So just a little algebra. I'm using your properties. You've probably done this before with other types of functions, right? Other properties of exponents, of logarithms, composite functions, and so forth. So same idea.